Today, folks, we are going to do the second part, our second equation, dealing with reaction prediction, and that is a decomposition reaction. Well, if we were just thinking, all right, I'm just thinking here, what is happening if something decomposes? It is breaking down into smaller things, correct? So, that's the same thing that's happening with our decomposition reaction here. I have a compound, in this instance right here, it's compound AB, and it's breaking down into each of the individual elements, element A and element B. So the general format for a decomposition reaction is AB yields A plus B. Now, how are you going to identify these? You're going to look right here. You're going to look right here at what you are given. If you are only given a compound, one thing, you're going to say, oh, that's a decomp. That's a decomp. Now, I think I got a little picture here. There we go. Here we got Mickey and Minnie together. Okay? And when they break down, they just break down to their individual Mickey and Minnie. AB yields A plus B. Now, the very first one is a metallic carbonate heated will break down into a metal oxide and carbon dioxide. The very first one we're going to work is calcium carbonate. Now let me ask you this. Right here. Here is the symbol for something being heated. If we don't heat this, will it happen? Do you remember when you put the sodium bicarbonate, the baking soda, into a crucible? Did we do that already? I think we did. Okay? If you put baking soda into a crucible, it's never going to do anything. What do I have to do to get that reaction to occur? I have to heat it. There's a certain amount of energy that needs to be hit for it to break down. Now, I have the conditions here because it says that it's heated. So calcium carbonate heated will break down to a metal oxide and carbon dioxide. Now, to me, folks, we know carbon dioxide, don't we? CO2, that's pretty easy. Now, let me ask you this. What is the name formed of my metal oxide? Calcium oxide. Now, if you need to write down like I was doing earlier, write the word and the charges and the likes of that to get the formula, great. What is calcium? Calcium's a 2+. What is oxygen? 2-. So right there is calcium oxide. Last thing I checked, do I have a balanced chemical equation? Absolutely. So that is the decomposition of calcium carbonate. Now this one you're going to see, it's going to be, it looks like it's a little bit more difficult. What lead do I have there? What lead do I have there? How do I determine? I look at the carbonate, right? What's the charge of carbonate? 2 minus. How many carbonates do I have? So my total carbonate charge is -4. So what's my lead got to be? Lead 4. Now let's make sure when we're doing this that we keep our lead consistent here. So, once again, I know what carbon dioxide is going to be. What is my metal oxide form? Be careful. What is my metal oxide? Name it first. Now be careful. Lead 4 oxide. So what's lead 4 oxide? PbO2. Now I'm absolutely 100% going to have to balance this, and I don't like balancing these because it's one of those kind where my polyatomic has been split up. So that makes it even tougher. I'm going to look at that carbonate first. Okay, I have CO3, 2 of them, so I have 6 oxygens. How many oxygens do I have over there? 4. But in my vision, I can see that I'm going to need 2 of those. So if I put a 2 right here, I take care of my carbonates, and I have now 6 oxygens, right? So am I good? Yeah, I'm balanced. So that was easier to balance than what I thought. Yeah. Maddie. How did I know that was lead 4? Carbonate as an ion. It's a polyatomic ion, right? The whole ion has a 2 negative charge. There are 2 of them. So the total charge for that carbonate is 4 minus. I only have 1 Pb, so it's got to be 4 plus. My second decomposition reaction is a metal hydroxide heated. A metal hydroxide heated will yield a metal oxide and water. Here is a metal oxide, a metal hydroxide, magnesium hydroxide, heated, metal oxide, and water. Well, once again, water I'm okay with. What's my metal oxide going to be in this case? Magnesium oxide. Both have a 2 charge. Magnesium is 2 plus. Oxygen's 2 minus. So it's simply MgO. And I look, is it balanced? It is balanced. Remington? Why do I have to change the order? Why is O first here and H is first over there? Well, because hydroxide, okay, when we're talking about, it's back to bonding. Okay, oxygen's going to be in the middle, and the hydrogens are going to be around it. Okay. For water here, the oxygen once again will be in the middle. The hydrogens will be around it. Yeah, I guess I'll answer your question like this, because I know water is H2O and I know hydroxide is OH minus. Okay, from my ion sheet. FeOH3. Once again, I look at this and I see that I have iron. Okay? I see that I have iron. What iron do I have? I have iron 3. So what is my metal oxide that I'm going to form? Iron 3 oxide. What's iron's charge? 3 plus. What's oxygen's charge? What's oxygen's charge? 2 minus. So Fe2O3 and H2O. Now, I'm looking at that and I'm saying that can't be balanced, can it? Absolutely not, because the first thing I see, the very first thing I'm going to do is put a 2 right here. Because I know I have 2 irons. So I'm not even going to worry about my hydrogens and oxygens until I get my 2 irons. Then I'm going to look and see how everything's affected. I have now 6 hydrogens and 6 oxygens, right? Over here. Over here. I have 6 oxygens and 6 hydrogens. Well, come over here, I've already got 3 oxygens there. If I put a 3 here, that gives me 6 hydrogens and 6 oxygens, right? So that balances me out. Garrett? You're okay? Huh? Our third type is a metal chlorate heated will give me a metal chloride. Here is a metal chlorate, potassium chlorate. If I heat that, what is my metal chloride formed? Potassium chloride. What charge is potassium? 1 plus. What charge is chlorine? 1 minus. K, Cl. And oxygen. What's oxygen? O2. It's a super 7. Now all I have to do is balance it out. I'm going to start right here and put a 2 here. The reason I did that is because this oxygen right here is odd. I need to have an even because I can't make O2 into an odd number. So now I have an even number of oxygens, correct? So if I have a 3 here, I have my oxygens covered. All I need to do is put a 2 here to have my 2 potassium and 2 chlorine. Here's aluminum chlorate. It's heated. So, what is my metal chloride being formed? Aluminum chloride, which is what? AlCl3 plus oxygen. Now, once again, same thing with my oxygens over here, right? Same thing with my oxygens. This is 3 times 3. 9. That's an odd number. That's an odd number. So I'm going to put a 2 here to make that an even number. Now I've got how many oxygens? 18. It would be nice if this would work out. I'll put a 9 there because 9 times 2 is 18. And I go back and look. I have 2 aluminums left and 3, 6 Oh, I only got 3 times 2. Okay, yeah, I do. I got 6. 3 right here times 2 is 6. So if I put that 2 there, I'm balanced. The fourth reaction of a decomposition is a metal nitrate heated. A metal nitrate heated. Now, folks, as far as these things, you just have to recognize, I used to make my kids memorize this equation right here. Okay, I used to make everybody memorize those. I'm not going to make you memorize those. If we know how to use these using our packets, I think we're okay. Or at least me giving you a sheet that says a metallic nitrate heated yields a metallic oxide, nitrogen dioxide, and oxygen. I might play it that way. But nonetheless, a metal oxide, except group 1 below lithium. These convert to nitrites and oxygen. So here's an exception, and that's one of the tough things about chemistry, is that there are a lot of exceptions, especially if you ever go on to take organic chemistry in your life. Okay? Except for group 1 below lithium. So if I have a group 1 below lithium, it's a little bit different. Just be aware of that. Calcium nitrate. Well, what's this going to break down to? What's my metal oxide? Calcium oxide, which is CaO plus nitrogen dioxide plus oxygen. Now, this could be a balancing nightmare. Okay, I check my calcium first, it's okay. I have 2 nitrates, right? Or I have 2 nitrogens right here. So I'm going to put a 2 right here to start with. Now my nitrogens are balanced. Okay. Now I'm going to come back and look at my oxygens. How many oxygens do I have? I have 6 right here. And I have 2, 4, 6, 7. Uh-oh. That didn't work, did it? That did not work, putting a 2 there. So what am I going to do? I'm going to bring a 2 over here, which now what am I going to have to put in front of that nitrogen? A 4. So now I have 4 nitrogens. 4 nitrogens. I have 2 calciums over here, so I'm going to put a 2 here. 2 calciums, 2 calciums. Now I need to go back through and look at my oxygens. 3 times 2 is 6 times 2 is 12. Here is 8, 9, 10, 11, 12. That did it. So once again, the balancing can be trial and error. Can be trial and error. We tried, it didn't work. We went back again. Here is aluminum nitrate. So what am I going to have formed here? What's my metal oxide is? Aluminum oxide. Plus nitrogen dioxide plus oxygen. Well, what charge is aluminum? Aluminum's +3. What's oxygen? Yes, a +3 and a -2. If we do the crisscross, it's Al2O3. That's the last chapter. Well, actually, that's 2 units ago, right? Naming things. Now, I got to balance this guy. I've got to balance this guy. Where would you start? I'd start right here because I know I need 2 aluminum. Okay? I need 2 aluminum. How many nitrogens do I need? 3, 6. So am I going to put a 6 here? Have to, right? How many oxygens? 9 times 2 is 18. I've got 12, 13, 14, 15, 16, 17. Doggone it. I'm 1 short. So, I got to go back to the drawing board. Now, do I need to put 3 there? I just had 2 for aluminum over here. Do I need to put a 3 there? Yeah, that would make it odd. Do I want an odd number there for aluminum? I can't have it. So I don't even need to put 3. I know it's not going to work. I'm going to put a 4 there, which would make me put a 2 here. So now I've got my aluminums okay. I say 3 times 4 is 12, right? So how many nitrogen am I going to need? 12. That's a big number, but can I have big numbers there? Three times 1 is 3 times 4 is 12. Okay? Now I count up my oxygens. 3 times 3 is 9. What's 9 times 4? 9 times 4 is 36, right? Okay? So I have 24 and 6 is 30. So how many more do I need? 6, right? Did I get 6? 3 there. So that was a little tougher one. Can I reduce anything? Can I reduce anything? No, I have to reduce all coefficients to be able to reduce anything. Okay? Naira? You're going to have to talk louder, hon. Everything. Everything. That 4 in front of the aluminum distributes to everything there. Yes. Yes. Correct. All right, continuing on. Okay, we just got done doing this. So let's now move to our 5th. We got 2 more of these to cover because there are 6 decompositions. There's only 5 combinations. So number 5 is an oxyacid heated. Will give me a non-metal oxide and water. Have you noticed, folks, that these are just the flip of the combinations? Okay? So, what's an oxyacid? What's an oxyacid? Number 1, it begins with H, correct? Okay? Then it has oxygen paired with some other non-metal. Well, the first one we're going to do is carbonic acid. Once again, it has to be heated. So, I need to just double check to make sure I have that little delta. That's a Greek delta. Have that little delta over there, which means that Okay, so I have my delta there. So, water and a non-metal oxide. Now, before, when we were doing combination, I told you what I think of when I'm doing this is I'm adding them together. Well, I'm doing it just the opposite if I'm dealing with a decomposition. So what would happen? What would happen? What would happen if my burner didn't work? What would happen if I subtracted an H2O from that? Think of it that way. Okay? Obviously, over here, I have the H2O of the water. What's my metal? Hey, what's my metal oxide gonna be? Well, CO2, right? Now, I'm going to get that out of there because we don't need that in there. That's just the mental thought I was thinking. Okay? Is that balanced? Yes. Sure is. Now, look at this guy. Nitric acid when I heat it. Now, what's the deal here? I don't have two oxygens, do I? Or excuse me, I don't have two hydrogens. Okay? I don't have two hydrogens. So the first thing I'm going to need to do is make sure that I have two hydrogens, right? So if I have two hydrogens, what happens if I take out two hydrogens and one oxygen? What am I left with? All right, not everybody at once. Give me a hand if you think you got it. Andrew? We'll go through. How many nitrogens with that two there? There's got to be two nitrogens, right? Because here I've got two hydrogens, two nitrogens, six oxygens. What's going to be left over if I take a water out of there? Right. N2O5. Now, we need to get it back under control here and quiet. Garrett's got a question, so everybody can hear it. Go ahead, Garrett. Here, if I were going to subtract water from here, can I take a H2 out of just one H? No, it's not going to work, is it? So if I'm going to subtract the water out of there, I've got to have two of those to get two hydrogens out. Okay? It's a great question. Yeah, Remington? For hydrogen to bond over with water? Well, it tells me up at the top. What do you mean? Did it tell you to do that? Well, yeah, but you'll know this. Okay? I'll probably give you a sheet of paper that has all of these on it. Okay? I'll probably give you a sheet of paper. Right, that's what happens. That's what it decomposes to. Water is one of the ingredients. Yes. Right. Yeah. And you should already. Okay? Back from your naming days. Way back when. Now, the last one's probably the easiest, I think. The last one, I think, is the easiest because it takes a binary compound, heated or electrolyzed, to give us our constituent elements. That just means to give us our two elements. So, here I've got mercury. Which mercury do I have here? Mercury 2 oxide. So what's that going to decompose or break down to? the constituent elements, which are what? Mercury and oxygen. But remember, oxygen's a diatomic. Always got to have it at O2. So now I have to balance. Where? It does. That means I have two of these. It's like having HGO, HGO. I've got two of them. So I've got two mercuries, two oxygens. Two mercuries, two oxygens. Our last one is water. Some of you folks, if you took IPS with Mr. Scott, you actually hooked up electric current onto water and collected into the two test tubes the gases, and then you tested the gases. You did it. Yeah, you did it. So, if I take water and I electrolyze it, I'm going to break it down into hydrogen gas, which is a super 7, and oxygen gas, which is a super 7. So once I break those two down, do I have to balance? Yeah. What, balancing it? Well, if I don't have the electric current, water won't break down.